Hey guys, so I wanted to go over a problem from quiz week 12 that was a little bit trickier. This was question number 12, where says Esteban poured himself a hot beverage that had a temperature of 198 degrees Fahrenheit, then set it on the kitchen table to cool. The temperature of the kitchen was a constant 68 degrees Fahrenheit. The drink cooled to 177 degrees Fahrenheit in 2 minutes. How long will it take for the drink to cool to 97 degrees Fahrenheit? So the equation that you'll be using for this is T of T. And even though you didn't have a problem exactly like this in the homework, you did have one that was a cooling problem. And so this is exactly the same. So S plus T sub 0 plus S. Oh, minus S. Minus S. E to the KT. So that's the formula you're going to use. So the first thing you need to know is that T sub 0 in this particular problem, T sub 0, that's your initial, equals 198 degrees, your initial temperature, and S equals 68. So you're going to plug those values in. So we're left with T of T equals 68 plus 198 minus 68 e to the KT. So then that equals 68 plus 130 e to the KT. Now the next thing to realize or to note is that they give you that after 2 minutes it cools to 177 degrees. So T equals 2 in this scenario, and 177 degrees is our final answer for T of T. So we're going to plug that in. So 177, we'll plug that in for T of T, equals 68 plus 130 equals, T equals 2. Oh, not equals, sorry. T equals 2. And K, we don't know K yet. Okay, so now we're going to subtract 68 from both sides. So that gives us 109 equals 130 e to the 2K. Oh, I forgot e up here. E to the 2K. Now we're going to divide by 130 on both sides. So that gives us 109 over 130 equals e to the 2K. Now, in order to bring down that exponent, we're just going to take the natural log of both sides. So I'm going to give myself a little bit more space. I'm going to go up here. So natural log of 109 over 130 equals the natural log of e to the 2K. So now the natural log just cancels itself out, and we're left with natural log of 109 over 130 equals 2K. Okay, so now we're going to divide everything by 2 to isolate K. So we're left with 1 half natural log of 109 over 130 equals K. So now we know K. Now what we want to do is we want to find at what point does the temperature reach 97 degrees Fahrenheit. And so to do that, 97 is going to be our T of T, so we're going to plug 97 in for T of T equals 68, which we already figured out from earlier, 68 plus 130 e to the 1 half, because this is K, 1 half ln of 109 over 130 T. Sorry, the handwriting's not great. It's kind of hard to read. T. And now we're trying to solve for T, for time, right? So we're going to subtract 68 from both sides. That gives us 29 equals 130 e to the 1 half ln of 109 over 130 T. Divide by 130 on both sides. That leaves us, here I'm going to give myself another little more space. That leaves us with 29 over 130 equals e to the 1/2 ln of 109 over 130. Sorry, I'm kind of writing to t. So we're going to do what we did earlier, and we're going to take the natural log of both sides. So natural log of 29 over 130 equals natural log of e to the 1/2 ln of 109 over 130 t. Okay, so the ln and the e, those are the same, so they basically just cancel themselves out, and you're left with the natural log of 29 over 130 equals 1/2 ln of 109 over 130 t. So now we're going to divide everything by that 1/2 ln of 109 over 130 and solve for t finally. So t equals 2, because you can flip that 1/2 and turn it into 2 ln of 29 over 130 over ln of 109 over 130. And it says to round to the whole number as needed, so just make sure you're really careful about the number that you're rounding to. But after plugging this into the calculator, it should be t equals approximately 17 minutes. And that's it. That's all you have to do to solve this one. If you have any questions, please feel free to ask. Otherwise, thanks for watching.